Welcome to the module Thermodynamic Data from NIST. In this module, I will outline the importance of having reliable thermodynamic data in chemical thermodynamics and introduce the NIST database. I will demonstrate how to find data describing various properties of chemical substances under different conditions. It is very convenient to perform many types of thermodynamic calculations using an ideal gas as the studied system. Often, these calculations do not require knowing the specific properties of the actual substances involved in the analyzed processes. If a gas follows the ideal gas law, very often there is no need to know much about the substance itself. However, this is not always the case. To thermodynamically analyze real substances, we need more than just theoretical concepts. We also need substance-specific data. For example, as I mentioned earlier, molar heat capacities at constant volume or constant pressure depend on the substance. This means that we cannot just introduce them theoretically. Someone has to actually measure these properties experimentally. Thermodynamic properties of various substances have been measured for over a century and have been summarized in various reference works at different times. The reason for this is that the availability of accurate thermodynamic data for chemical compounds is crucial for the practical applications of chemical thermodynamics in both research and industry. Now, let's look at what data sources are available for the thermodynamic properties we need, particularly in this course. We aim to utilize data from reliable databases, with one of the most prominent being the NIST Chemistry Webbook, maintained by the National Institute of Standards and Technology, NIST. NIST is a leading organization providing standardized and comprehensive thermodynamic data for many substances. The NIST Chemistry Webbook database provides essential values for various substance properties, including molar heat capacity at constant pressure, molar enthalpy, molar entropy, and many others. These values are crucial when calculating the thermodynamic characteristics of chemical system based on their actual composition. In many of our course exercises, you will need to look up specific data in the NIST Chemistry Webbook. Note that this is not always straightforward. The provided values are substance-specific and must be correctly attributed to the substance phase and conditions, such as temperature and pressure. Consistently using reliable data sources is essential to ensure the accuracy and meaningfulness of our thermodynamic calculations. I strongly encourage you to familiarize yourself with navigating the NIST database. It will not only be indispensable for this course, but might also prove useful in your further studies and professional activity. Let's start by getting familiar with the NIST Chemistry Webbook interface, which will be our primary tool for accessing thermodynamic data. To begin, navigate to the NIST Webbook homepage. You will see a drop-down menu labeled Search at the top, showing the most common types of input information. Below that, you will find the Search Options section, which lists all the search possibilities available on the site. You can search by molecular formula, chemical name in English, common identifiers, or even by molecular structure. In most cases, you will likely use the formula or name search to find the substance you are looking for. Now, let's look at how to search for species data using a chemical formula. On this page, you can enter the desired chemical formula into the search box. Below the search box, you can select additional search options, such as whether to exactly match the specified isotopes, include elements not specified in the formula, or allow more atoms than specified. For most of our purposes, you can leave these options unchecked, but select the option Exclude ions from the search unless you specifically need data for ions. Next, ensure that you select SI units and select the desired units for thermodynamic data for consistency with our calculations throughout the course. Finally, choose the type of thermodynamic data you want to be displayed initially, such as gas phase data, condensed phase data, or phase change data, and press the search button to retrieve the results. A detailed description of these search options and additional guidance is provided on the same page below the search form. After submitting your search query, you will be presented a list of search results. In many cases, multiple substances correspond to the same chemical formula, such as various isomers of organic substances. The results display all matching species in the database with their chemical name, chemical formula, and structure image if available. This helps you to quickly identify the substance you are interested in. To access actual data, click on the chemical name of the desired species. This will take you to its data page. Now, let's explore how to search for a substance by its chemical name. On this page, you can enter the name of the chemical species you are interested in. You can use common names of chemical species for the search. You can also use partial name patterns with an asterisk to match any number of characters, broadening your search. Below the search box, you will see options to select the units for thermodynamic data. As before, select SI units to ensure consistency with the rest of our calculations. You can then specify the type of thermodynamic data you want to be displayed initially. Then press the search button to see the results. Depending on your query, you might also be presented with a list of matching chemical names, allowing you to select the species of interest. Additional guidance is provided on the same page below the search form. The data page for a substance provides access to detailed information about that substance. It displays only one type of data at a time, as specified in Information on this page section. However, you can easily switch between the different types of information available for that substance by clicking the respective links in Other Data Available. The types of information available include gas phase thermochemistry data, condensed phase thermochemistry data, phase change data, and many more. Now, let's focus on the section called gas phase thermochemistry data and consider the heat capacity as an example. For many substances, the molar heat capacity of a substance in the gas phase, specifically at the constant standard pressure of 1 bar, is provided at selected temperatures. These values are measured or calculated at different temperatures and are presented in a tabular form. The heat capacity is listed in joules per mole per Kelvin, while the corresponding temperature is presented in Kelvin. There are also references on the same page below. They indicate the studies from which the data was obtained, ensuring that the data is traceable and reliable. As you can see, for many substances, the molar heat capacity varies with temperature when a wide temperature range is considered. To describe this variation, NIST employs a specific mathematical expression known as the Shomate equation. It is a polynomial equation that allows us to calculate the molar heat capacity as a function of temperature. It is expressed as Cpm equals A plus B times T plus C times T squared plus D times T cubed plus E times T to the power of -2. Here, small t represents the absolute thermodynamic temperature in Kelvin divided by 1000, while A, B, C, D, and E are substance-specific coefficients. Now, I would like to discuss what these coefficients A, B, C, D, as well as F, G, H, used in related formulas, actually are. They are derived by performing a mathematical regression, which means fitting an equation of a predefined type, in this case the Shomate equation, to the reference data, such as the ones I have shown in the previous screenshot. As such, they do not possess any physical meaning. The individual coefficients do not carry any physical significance, but altogether as a set, they provide a convenient way to accurately calculate certain thermodynamic functions. In this respect, the coefficients have practical importance despite their lack of physical meaning. As you know, the change in molar enthalpy of a substance with temperature can be determined by integrating the molar heat capacity at constant pressure over a given temperature range. When the molar heat capacity is expressed using the Shomate equation, we can perform the integration in a general form, resulting in an equation that describes the enthalpy change with temperature. Specifically, this equation provides the value of the molar enthalpy of a substance relative to its value at 298.15 Kelvin. In addition to the previously introduced coefficients A, B, C, D, and E, this equation also includes two other coefficients, F and H. The combination of these last two coefficients, F and H, from the same set serves as the integration constant. It is important to note that NIST utilizes the symbol h for one of these coefficients. This can be confusing as h is also used as the symbol for enthalpy. This slide shows an example of the coefficients used in the Shomate equation as listed on the data page for a substance. These coefficients are specific to the substance as well as to its phase. Additionally, pay attention to the fact that NIST often provides different sets of coefficients for different temperature ranges. The range of validity of a particular set of coefficients is indicated in the table header. By clicking on View Table inside the section Gas Phase Heat Capacity Shomate Equation in the data page, you can access a table showing certain thermodynamic properties for the selected substance at various temperatures. The properties include the molar heat capacity at constant pressure and the molar enthalpy relative to the value at 298.15 Kelvin. This table can be utilized to quickly look up values at some temperatures. Pay attention to the units indicated in the table. Furthermore, the NIST website has the capacity to present data graphically. This can be done by clicking the View Plot link within the respective sections. As an example, by clicking on View Plot inside the section Gas Phase Heat Capacity Shomate Equation on the data page, you can display a plot showing the variation of molar heat capacity at constant pressure with temperature. This plot provides an overview of data. It is also possible to hover over the plot to read out individual data points. This can be another possibility to get a quick access to certain types of data.